Hello all. In this video, we'll be discussing about Leetcode problem number 13, that is Roman to integer. So here you are given a Roman numeral and you have to convert it to an integer. Say for example, this is the Roman numeral and it can be converted to an integer of 3. So this Roman numeral's value in integer is 58 and this Roman numeral's value in integer is 1994. So let's see how we can decode it. Before going ahead, we'll like to see the observations. The first says Roman numerals are usually written largest to smallest from left to right. So this is the generalized statement for Roman numerals. And the second observation is that if you are encountering a lesser value before the next higher value, this means you have to subtract that value. Say for example, here it is 5 and you have encountered a 1 before it, so it will be 5 minus 4. Otherwise, if here value is greater and this value, next value is small, so you have to just simply add it. So basically this will be 10 and this will be adding means 2. So it will be 12 for this specific case, okay? Otherwise, for this complete, you can just add 20 and then 5 and then 2. So with this observation, let's move ahead. So for this example, the first one, let's go one by one. So first, I'll be doing this in two steps. The first, I'll be checking that whether the next element is less than or greater than, and based on this decision I'll be adding or I'll be subtracting that value. Okay, so this will be my second step. So as of now I have declared a variable known as sum, which will actually store my integer value, and I have initialized it to 0. So now I'll start scanning the string. So the first character that I encountered is L. So say I have hard coded this value in a table such that I can get the exact value of this literal. So when I'll be looking that, so it will be 50 and the next element is less, this is greater than, 50 is greater than 5. So good to go. What I have to do is I have to perform an addition. So now in the next case it is 5. So 5 is greater than the next value, that is 1. So again I am good to go. I have to add that value. Now again in the next case I am having 1. So 1 is greater than equal to 1. So that's also it's fine. So I'll be adding that value, and similarly the next two values will also be added to this, and at the end we'll be getting an answer of 58. So now let's look at the second case. So here again, if we start scanning, and we will certainly initialize a sum of 0 at the start. So 1000 is greater than equal to C, that is 100. So it's okay. So let's add 1000 to it. Now when we'll be scanning C, so 100 is greater than equal to the next value, that is 1000. The condition is false. So basically I'll be subtracting its value from the sum. So I hope now the logic is clear that if a value, next value is greater and this value is smaller, then you have to subtract this value from the integer, that is sum. So now I'm again scanning 1000 is greater than 10, condition is okay, so I'll be adding that value to my sum. Next one, 10 is greater than equal to 100. See, that is 100, the next value? No. So here I'll be subtracting 10. So as of now, I hope it is clear that number is 2000 minus 100 means 1900 minus 10. Then now we are proceeding ahead. It's C. So 100 is greater than equal to 1. That's fine. Add 100 to it. means this becomes 90. And finally, you will be going with this 1 is greater than equal to 5, the next value? No. So you have to subtract 1, and then for the last value, you have to add 5. So this comes out to be 4. So now it is 1994, which is the required output. So I hope the logic is clear. Now let's go for the code. So first of all, we have just created a function which will return the values of the literals. In the second, we have just one pass, and we have stored it, the final answer integer, in a variable ans. Then we'll be comparing if next value is greater than the earlier value, then you have to subtract. Otherwise, if next value is smaller than the earlier value, then you have to add that to the answer. So at the end, you have to append the last digit to it, the exact value of the last digit to the answer, and then finally you have to return that answer. So as of now, if you just look at the time complexity, it just comprises of number of digits or number of literals in the Roman. So you can just say if it will be represented by D, then you can say the time complexity is O of D. And space, it is just O of 1. So that's all. Thank you for watching. Have a nice day.